Good day everyone, this is Daniel Pinheiro from danielpm1982.com. Welcome to one more video. So in this series of videos about Docker, if you lost the previous videos, just go to the link of the YouTube playlist that I leave at the description of this video and watch the other initial videos. Because this video is all about how you'll be able to create or Dockerize a real Spring Boot application into a Docker image and share that at dockerhub in order to show you a more realistic example compared to the other one we did in the last video, which was simply a Hello World application. So it's not actually a commercial application, of course. It's still a sample application, but it's more realistic than the other application we've shown you in the last video. So the first thing would be to create the Spring Boot application. And of course, I won't do that because it would take a lot of time. This video is not about Spring or Spring Boot framework, so I decided to use one of the Spring Boot applications I had created a couple of years ago. And then we will take that application from GitHub, from my GitHub profile or account. We'll clone it locally using IntelliJ IDE. Then we'll use Maven to go every building step of a creation of an MVC application. And finally, Maven will deliver us the final jar or the final executable Java application that will have not only the application sources compiled, but Tomcat and other dependencies needed to run that application simply from that unique jar file. And later we'll take that jar and we'll Dockerize it and run it from Docker engine to show you how to run real applications from Docker. Of course, we could run it from the Java command, but the idea here is to show how it is possible to run it from inside a Docker image or container, so that anyone that eventually pulls it or downloads it from dockerhub, for example, could run it without having to install any other dependencies locally. For example, without even have to have Java installed in their local file system, because everything will be inbuilt not only inside the jar, but also inside the container or Docker image we'll create. So let's go to GitHub in order to clone that application that I have already created and committed there. So github.com/danielpm1982. Here's my GitHub profile. So if you wanna check out my repositories, my public repositories, you can go here. And the application that I wanna exemplify in this video and Dockerize it is this one, springboot 2-meeting-manager. So you can click on it. Then for downloading it or cloning it, you can just click here at code button and copy this link here in order to clone it locally using git CLI at the console or using your preferred IDE. In our case, we will use IntelliJ IDE. So we are copying the link to this repository with this application, springboot 2-meeting-manager. And now what we just have to do is to open IntelliJ IDE and create an application from that GitHub link. So you can start here a new project, you can open an existing local project, or you can get directly from your version control system application or remote application, in our case from GitHub remote repository. So click here get from VCS or from GitHub in our case, and paste the URL for that remote repository without the Git. So you should not use the .git extension, just exclude it. So here is the URL of that remote repository for that remote application that I have at my GitHub account. And this is the directory where it's going to be cloned locally. And I have already set my preferred location here, but you can, of course, change it to any location in your machine you want in order to IntelliJ to have that workspace to work locally with that application we are cloning. So here is the URL, here is the local directory where it's going to be cloned into. So just click on clone, and it will clone from that remote repository from GitHub and save it locally here at this specified directory. So clone. Here you have the whole application we have there at that remote GitHub repository. We now have here at this local Git repository or directory managed by Git, and we can now work with it, including building the final executable Java file using Maven. So let me just show you quick here what we have in this MVC Spring Boot application. So as any Spring Boot application, we have the main class here that is the start point that is used to run the application. So you can open and read some of the comments I've done. It basically starts the application and calls some initial tests and sample data that I have used to populate the database we'll be using as the application runs up. We have the domain classes, for example, person, event, place, and meeting. And for all that entity classes, they are all the classes we're going to persist in our database. You have here all the JPA annotations needed to mark them as entity classes, the primary keys, the columns, the enumerations, and the relationships of each entity with the other entities, as in any traditional MVC application using JPA. So we have the person class with these attributes and relationship. We have the place entity class, similar to the person one, with its mapping configure also here. We have the event entity class, also mapped here. We have the gender enum or enumeration. And finally, we have the main class, which is the meeting class, which is also an entity class, and it will be related to all other entity classes. For example, to the person list, to the place, and to the event. And also we have all its own attributes here to map the meeting or to create the meeting that basically is the objective of this application. So as we map it here, our data model, what we are creating is a meeting with a list of persons that will be part of an event and will take place in a preset place that we'll be able to choose from the meeting GUI view. So that's basically it. The purpose of this application is to create a meeting between persons as part of an event and in a certain place. And that meeting, of course, will be persisted in our database. For now, we're using H2. Also, now that I'm already here at application.properties, just one tip that I wanted to give you right now is that we would have to include this property here, spring.h2.console.settings.webAllowOthers equals true. So you can run the application locally without this property, but if you want to run from inside a Docker image or container, you would have to add this line or property so that the application would be able to run. Otherwise, the Docker daemon will return an error message saying that it's not possible to access that H2 server. So if you want to access that, you gotta add this line to the springboot application you're dockerizing. So, and this is the H2 URL that you should go. It will be available from the root context. So our base context URL will be http://localhost:8080. And if you also put /h2, you go to the H2 console or GUI so that you can view the tables and all the database data we're managing. This other line here is simply to add a banner that, in my case here, is this text, lineupm1982.com. And that's basically it for our application properties. So if you don't know anything about Spring Boot, don't worry, because there are many courses about it if you want to be a Java developer. So Spring Boot is by far the leading web application development framework we have. And that's why I wanted to show you not only that simple Java application we used in the last video, but a full MVC Spring Boot application with all the layers that comprise an MVC application. So as I've shown you already, we have the entity classes. We also have the repository classes, which are basically classes to manage the persistence and the queries from the database we're using, in our case the H2, but later with MySQL or any other database you configure here at the application.properties. So for example, person repository will manage all the queries. In this case, I'm only using this customized query using JPQL, but as we're extending the CRUD repository interface, we'll also be able to use all the other methods that Spring Data turns available from any class that extends this Spring Data interface, CRUD repository, and here the type of the object we are managing, which in this case is the person object, and here the long is the ID type for the primary key of that object at the database. So that's how we use Spring Data. We simply extend one of the interfaces that Spring turns available for us to use. In this case, we're extending the CRUD repository, and if we want, we add as many customized queries or methods here inside this interface, but you could even not use any one and keep with only those offered by Spring Data that are automatically implemented inside by Spring. But in our case, I wanna use also this other method here. So we also have the place repository with some other queries. We have the event repository, all of them extending from current repository and adding some customized query methods for us to use, and also the meeting repository. Okay, so these are the repository classes, and observe that all of them are marked with the Spring Bean annotation at repository, so all of them are Spring components that will be managed by the Spring context for the inversion of control and for dependency injections and so on. So I've shown you the entity classes, the repository classes, and now we have the service classes. I basically join here all the repository methods we can use, so that in the controller we simply inject this service and make use of any of those methods that are implemented here and call any of the methods we want. So I'll not enter in details about how to implement this. You can see all the application and the implementations at my GitHub profile by accessing that remote repository for this application. So I'll keep the focus here, which is basically how to build this application and Dockerize it. So we have the entity classes, we have the repository classes, we have the service class, and here we have the controller classes, which basically will manage the requests from the clients, direct that to the data layer, and later get the response from the data layer, which are all these packages here, and send that to the view layer, which basically will be the HTML files created from the time-leaf templates that I have here. So all the view layer will be generated from these time-leaf templates. If you don't know time-leaf, also there's no problem in that. But if you wanna develop in Java, especially using Spring Boot, that is a very common technology to use alongside Spring Boot. So you can use JSPs that I have used a lot, but nowadays it's better for you to use as an HTML template generator, not JSPs, but time-leaf templates. We have here the welcome page template, update meeting, show meeting, places, persons. All of these will turn into HTML files that will integrate our view layer of this MVC application. So let me close here. So these templates will be our view layer. The domain, auto attribute beans, the repository, and the service will be our data layer. And here is the controller layer. For example, the person manager controller, we inject the service, which will be a single class that will contain all the repositories injected inside it, and through it we'll be able to call any of the methods we implemented here at the data layer. We have here a constructor injection of this meeting manager service interface, And we won't have to use the qualifier here because there's only one implementation for it. So we inject in here according to each URL or each path for each request mapping. We call the interface methods related to that request, and then we send to the template for the template to use all the attributes added to the model and render the HTML for the view. So if you wanna see the persons available, Springboot will direct to this method of the controller. It will call this method find all persons from the injected meeting manager service interface. It will add to the Springboot model object the person list, and at the persons template, if you see here, persons.html, it will get that person list in order to iterate it and show to the user if the list is not empty. So it will get the list and it will get all the properties of that list in order to show to the client. So for each request mapping URL or path, we will have a response to a view, and the controller will be responsible for managing all that flux. So we'll be able to list all the persons, we'll be able to add a person through this path add person form, and also to a confirmation page, and later the redirection to the person list page again. So this is for the person manager controller. You have the controllers for all other related entities, for example, for the place, for the event, and for the meeting. So as you see, it's not a simple or a small application. It's almost a real Java Spring Boot application that I chose to reuse in order to show you how to build the final jar using Maven, and after taking that jar to create or dockerize it using the Docker engine. So this is the Spring Boot application. If you didn't understand how to create a Spring Boot application, you can choose a course at Udemy or look for any tutorials or for Spring Boot documentation on how to create a Spring Boot application. The thing here is that we have cloned a Spring Boot application from a remote GitHub repository, and now we're going to create the executable final Java jar file and later dockerize it. So now we have the application here locally. If you see here at the folder in which I chose to clone it, you have here the application. Observe that you don't have the target directory, which is the directory where the final application will be saved into. And now what we have to do is use Maven, and we can use this GUI from Maven inside IntelliJ to simply run all the, or at least some of the steps of the building process to create our jar package. And this package will include not only all this application after its compilation, but also a Tomcat platform and an instance of it that will be embedded into that single jar file. So only with that single Java jar file we'll be able to run the whole application locally, or we'll be able to dockerize it into a Docker image and turn available that image for others who would like to run the same application in their machines from Docker. So we can simply call here, if we had any target already created here, we could call the Maven clean. We don't have, so it won't make any difference here. But generally we call the Maven clean and later Maven install or Maven package. In our case, we just want the package, the jar package. So we call it, we double click here, package, and it will build the target directory here with the whole compiled application inside it, along with the Tomcat and all necessary dependencies, so that we can now manually get this jar, final jar here, and Dockerize it. So if we go here now to the folder, we have the target folder now, and inside that target folder we have the only file we need for our Dockerization, which is the application jar file. And if you see, there are two jar files. We gotta get this bigger file, it's 41 megabytes, that will include all the dependencies, including Tomcat, that we need to run the application. It's a web application, so it needs a web server to run, and that web server will be the Tomcat embedded inside this Maven jar file here. So now we simply copy this jar file to another folder, and I already have created that folder at my home temp. So I'm just copying that jar file here. Okay, and these are the two basic things that we need to create our Docker image for this application. We need a final jar created, for example, from Maven, including all dependencies needed, including the web server. And we need the Docker file, which is the script that the Docker engine will use to send all the information needed to the Docker daemon servers running locally in our system. So now let's go back to our console, and with these two files, two simple files, we're gonna create our Docker image. Later we'll test running it initially locally, then we'll send that Docker image to dockerhub. Later we'll erase all Docker images and containers and internet and volumes you have locally, and then we'll go to dockerhub again and clone that Docker image back to our local file system in order to run it again and test the whole process we've already seen in the last video, but now with a real springboot application that actually has a full persistence layer, in our case here with the H2 relational DBMS. So let's back to the console. Okay, so here at the terminal, let me go to the temp folder that I have already created and where I've put that jar package. So here we have basically these two files, the springboot 2 media manager 001 snapshot.jar, which is the package Maven springboot application that we've built with Maven using IntelliJ IDE, and we have already this text file Docker file without the .txt. It must not have the extension at the file. So if you want to reproduce what we are doing here, and as we've seen in the last video, you gotta create a Docker file without the extension. And inside that Docker file, you gotta put some basic script commands, as we've also seen in the last video, which is the from command and the base image we'll be using now, which is the same we've used for the last video, openjdk column the tag latest. Then you gotta set the worker directory or folder as the working directory for the volume inside your Docker image or container. So here we will just leave the root directory, so everything that we copy to the volume of that container will be put inside this working directory here, unless we set a different folder, and that will be relative to this one, because this one is the working directory initially. Then we gotta expose the ports that the container will be using to run our application. So it will expose its 8080 port from the Docker container, and we'll be able to map that Docker port to our local file system port. In our case, also 8080, because we're gonna access this application through the browser. So when we run the image, we'll make this mapping between the 8080 port from the local host to the 8080 port from the Docker image or container. Next, we set a command to copy this jar executable file already packaged with all the dependencies inside, and we're gonna copy from this current directory. This file is this same file here, and here is the destiny for the copy, which will be the working directory, which simply is this slash here, along with the destiny name. If we want the same name, we can omit the name here of the destiny. It will simply repeat the origin name. But if we want to rename that origin file name to a new file name, as we are doing here, meeting-app.jar, it's a simpler name, just declare it here at the destiny argument value for the copy command. So we are copying this file from this origin to this destiny. And next, in the last line, we simply run this destiny file from the working directory. So it's a cmd command with a JSON format instruction that calls java-jar and the name of the jar executable file inside the Docker container volume that we want this image or Docker container to run when it starts. But basically, it extends a base openjdk column latest image. It sets a working directory. It exposes the 8080 port from the Docker container. It copies the jar file from the local file system to a destiny inside each Docker container volume. And lastly, it calls java-jar and that destiny executable Java file in order to run our springboot application from inside that Docker container. So now, before we create our Docker image, let's first test if this compiled jar package is running OK. So we can simply use java-jar and the name of the jar file, and it should run as it runs inside the IDE. Okay, it's running fine. This is the Bootstrap data population that I have programmed to run when the application runs, so that we can have some data persisted at our database. And if you see here at the starting of the application, you can see that Spring Data is running. Here you have the port that we're gonna use to access the application through our browser. Here you have Tomcat 9 running from inside the jar file. As I said, the jar file that Maven creates from a Spring Boot application already has an inbuilt Tomcat web server inside. Here it initializes the application context that Spring uses to manage all the Spring beans. The starting has completed, and if you see here, you also confirm that the H2 console is now available at the relative path H2 relative to the localhost column 8080, and you can access the database that we're using. Actually, this instance of that H2 database, jdbc column H2 column mem column test db, from the H2 console accessible through this relative path. Here we have some Hibernate default configurations being set. And finally here we have the context path, which also I have not set any custom path specifically, so it will use the empty context path right after the http / localhost colon 8080 and slash. So that's the context path for the application we are running here. So the application has started. Down below, I just populate some data at the database so that we can see some data inside through the view. And now also, if you see here, the application is up and running, and we just have to go to the browser and access it through http / localhost colon 8080 port and slash. This is the context path of the application where the application is deployed in the inbuilt Tomcat web server. So if we simply go there, it will access the application which is running in the background. So this is the meeting management application. Here is simply a date for today. And here are some image buttons that we can click on in order to go to the specific section of the application. So here we have the section for the meetings display and also for meetings scheduling. Here are the persons section, which simply manage the persons stored at our database or application. Here is the events section, which manages the events stored, and here is the places where we can set the available places so that the meetings and the events can select from. This is as I said, a simple application that I had done a couple of years ago, and that's available at my GitHub account. at the same remote repository used to clone that to our local system and that we are running here right now. So if you click here, first at places, if you see, it's going to the database and is retrieving a list of places already stored there. And for now, we only have one place stored. We can add new places here. And the places simply have these attributes or columns here. ID, which is the primary key of the places. We have the street number, the zip code, the city, the state, the country. Here we have any details you're gonna add about that place in particular. And here we have the relationship to the meeting list, showing all the meetings scheduled taking that place as the place where the meeting is about to happen. And in our case, we have only this meeting, but we could have here a list of more meetings if we had used this place to more than one meeting. So as I said, you can add here a new place, add a place, a street number, zip code, city, state, country, and details. I should just click add, or you could clear to type all again. It should have here another button for going back to the last screen. So here is the place section. We also have the persons section. Let's go there. Okay, we have 3 persons at our database that are stored at the initialization of the application, as I showed you. We have the name, the gender, the birth date, the email, the position, company, and any details you want to add for that person being added. So as soon as we add any person, it goes back here to the person list and shows that person in this list. So we have now 3 persons with an ID, the name, the gender, the position, company, birth date, email, details, and the meeting list with all the meetings that each of those persons is expected to attend. So in this case, we have only one meeting scheduled in our application, and that meeting includes all 3 persons at the same meeting. So we also have, for example, this person 1 is expected to attend this meeting with ID 1, which starts at this time. But if you click here at this button, so if I want to know which meeting is that, I simply click here at the details to see which meeting that person 1 is attending. So in here we have the single meeting with, in our case, the ID equals 1. In here at the table we have the ID, the start and end date times, the list of persons expected to attend that meeting, the place and all details for the place where that meeting is expected to occur, the event regarding that meeting. So one thing is the meeting, the other thing, another object or modeling object is the event. And here it shows all the event details. And finally here it shows some other details that we would like to have outputted here for the specific meeting. So if we go back here, we go back to the persons list, and as the only meeting expected for them to attend is the same, if we click it here at the other meeting IDs button, it would go to the same meeting we've already shown with the ID 1. It's the same meeting for all 3. But we could, of course, create many other meetings and events that would differ between the persons expected to attend. So this is the persons list associated to the meeting list. Next, we have the events section, which is basically a list of events stored at our database. In this case, we have only one event with the ID, the name of the event, the theme about the event, the outfit that attenders should use, the host of that event, the capacity of attendance of that event, any details about that specific event, and here an association with the meeting that's associated with that event. So we have the event and we have the meeting, and the meeting in this case including all the persons. Let's click here again. It's the meeting with ID 1. If we click on it, it goes to that same meeting description because it's the same ID with the ID, start and end, date, times, person list, place, event. It's the same event here, and details. So this is the events list. Of course, we can add another event with the name of the event, the theme, the outfit, the host, the attendance, capacity, and some details for that event. And finally, we have the meetings section, which is the main section of this application, where you can add any number of meetings here, defining the start and end date times for that meeting, the person list, and you can include any of the persons already available from the database. You gotta first add those persons, then you can select them here when creating a new meeting. The same way you can select an already existing place for that meeting to occur. So we first gotta add a place, then select here when creating a new meeting. The same for the event. You first can add an event and later select here when adding a new meeting and the details for that particular meeting. So if you see here, we also have some buttons. In this case, we have only one meeting, so this meeting has an ID of 1 and we can see the details of it. If we click here, it goes to that same screen of meeting ID number 1 with the start and end dates and details about the persons expected to attend, details about the place, event, and some details directly related to the meeting. We can also update the meeting. We can delete this row of the meetings list and so on. So this is the whole application, and you can see that it has all CRUD features implemented using JPA and mapping through Hibernate those JPA object entities to an H2 in-memory relational DBMS, which is the H2 database. So all of this means that the application is running. So let's go back to the console or the terminal. If you see here, the application is still running. For it to end, you can use Ctrl+C. Now it's not running anymore. If you go back to the browser and try to access it again, of course it won't run because it won't access the application because the application is not running anymore. So our Spring Boot application is pretty functional and all packaged already inside this jar file, along with all its dependencies, the dependencies needed for it to run in the embedded server. And we have already created the Docker file with all the script commands needed to create our image. So now let's use Docker CLI to create our image similarly to what we've done in the last video, but now instead of with a Hello World very simple application, we are using this Spring Boot enterprise application built with Maven and with a Tomcat embedded server inside. So how you create an image when you have the application.jar and the Docker file already created, you simply use sudo docker build -t for setting the tag value or the name of the image. In our case, let's set as meeting app. This will be the name of our local image. And finally, a dot that represents the directory where the Docker file can be found, which is actually the current folder. So sudo docker build -t, the tag or the name of the image, actually we can also define here, right after the name of the image, a tag, for example, version 1.0.0. So now we have the image name column, the image tag, and lastly the folder where the Dockerfile script can be found to implement this building. So let's just click enter. So it's retrieving the openjdk base image from dockerhub, as we don't have it locally. So it's downloading that base image in order to extend it with the other layers we're creating for our own image with the commands we set at the Dockerfile script. So every command in a Dockerfile script is a new layer. For example, the first layer is to include the base image, in this case the openjdk latest image. The next layer is the second step here, which is the definition of the workdir or working directory space inside the volume of the Docker container. The next layer is to expose the port of the Docker container that we're going to use or that we're going to map when we run this image. We're going to map this internal Docker port or to a local file system port, which will also be 8080. So when we run the image, we map those ports from the port inside the container to the port outside the container that we're gonna use in our operating system. So the next layer is the copying of the local jar to inside the future container working directory with a new name here, as we wanted to rename it. So inside the Docker that will be created from this image, and at the root folder of the volume of that Docker container, we'll have the meeting app.jar, which next will be run through the java-jar and the meeting app.jar line of command. So this is our image. We have created it successfully, and it has been tagged also successfully as meeting-app version 1. So we can also see that by using sudo docker images, and we will have two images. One is the base image that is downloaded in advance, as it will be used to create our own image. So it first downloads the openjdk image from dockerhub and later use that to be extended and saved to our own image meeting app with the tag version 1.0.0. So now our image is created and available locally for our Docker engine or for our Docker daemon service to run. And now what I want to do before we send that to dockerhub is to test it locally. So for testing our image, we are gonna use sudo docker run. We'll be running it in the iteration mode in our terminal. If you do not use the -it, it will run in the background as a detached mode. You could also do that, but I want to show you the application outputs here. So I'll choose for now the iteration mode, sudo docker run -it -p for mapping the ports. And the ports we will be mapping are the 8080 local file system ports to the 8080 port of that Docker container that will be created from this image. So this second port here is the port inside the Docker container. And this first port here is the port of our operating system file system. So next we simply use the image ID or the repository name with the tag. So let's use here the image ID. So sudo docker run -it for the iteration mode -p 8080 8080 and the image ID. So let's click enter. Okay, it's created the Docker container and it's running that same jar application, springboot application, from inside the created container. So if you see here, you have the same outputs we had when we tested the jar application outside Docker. Here from inside Docker we have the same outputs. If you see the port, local ports 8080, this port is the port used inside Docker, so it will be mapped to the external port 8080 from our operating system. The embedded Tomcat web server that is running this enterprise application. The Spring application context being initialized. The H2 console also being initialized and turned available through this relative path to our context path. And at this H2 database instance and all other database and JPA and Hibernate properties being set. And finally, the application context path, which is simply empty. So the same way, now we can, as the application is still running, we can go to the browser now and try to run that through our local host column 8080. So this path will access through the local operating system 8080 port that is automatically mapped to the 8080 port inside the Docker container, and will access the context path of the application, which is simply empty. So we simply put / here, and we should access the Springboot enterprise application from inside the Docker container created from that image we've just created. So okay, here is the same application running, but this time from inside the Docker container. If you click on any of the buttons, it will also display all the expected data. Let's just test to add some data here. For example, let's add a fourth person here. Add new person, name Daniel. Let me put some mock date here. some email. Okay, and let's click add. So it's gonna add this new person instance or this new person set of data to the expected table at the database through JPA Hibernate using our Spring Boot application. So let's add it. And so it's redirected to this person list. And now we have the fourth person we've just added. So we can add any number of persons and that person will be persisted at our database configured for the application. We could also do that for a new place here, for some new event, and of course for the meetings, which is the main table or the main entity we have here being mapped with our database. And one last thing that I'd like to show you as a test for this application would be the H2 console. If you remember, it's mapped to this path here, which is the context path / H2. So if you use this path, it will direct to the H2 database console. And here at the JDBC URL, we gotta set not this one, but the instance that's been created for our application, which is this one here. JDBC column H2 column mem column test GB. Let's just copy it here to the H2 console. Username, we're using the default, which is SA. The password we are leaving empty. We could have defined the username and a password at the application.properties file at our Spring Boot application, but we're using here just the default values. We only have to change this H2 instance name in order to the H2 database to find the instance of the database being created and connect. So here is the H2 console. It shows here all the tables at the database, at the relational database we're using. The event, the meeting person table, the person, and the place. So through this H2 console, we can do any kind of search. For example, select star from person. If you run it, you see that it fetches or queries for all stored person IDs. And we have not only the 3 initially stored ones, but the 4th one we added at the application. So this proves that what we are doing at the application is actually being persisted at the final database. And that's basically it. So not only we are running the application from inside a Docker container and also the Tomcat web server, but we're also running the H2 database DBMS and also its console, as well as any persistence on it from the application. So this proves our application is running, so we can close it. And now if we use sudo docker images, we have those two same images, but if we use ps-a, we'll see that as we exited the application, now the status of the application is not up anymore, but it's exited. So if we try again to access the application from the local host, you see that we won't have any application running or accessible through this port, not any web server also, because we are not running the jar anymore, not inside the Docker container, nor directly at our file system by using, for example, the java-jar command. So, and for us to rerun that same container instead of rerunning the image, we can simply start the already existing container by using sudo docker start -i for the interaction mode and the container ID or the container name, and press enter. So it will not create another container, it will reuse the container already created from the meeting app image. Okay, now it's running the Springboot application, and when it starts we can now go again to the browser and do a refresh at the localhost column 8080 port, or with the slash here for the context path, and the application will be available again from inside the Docker container, as well as the H2 console. So if we go here to the person list, you can see that the fourth person that we added here is not available anymore, because what we are using here is the H2 relational DBMS, and that database management system is an in-memory system. It's not a physical persistent database, so it's not saved anywhere at the file system other than at the memory while running the application. So when we close the Tomcat, or when we close the server or the application, the database we've altered is simply deleted. And that applies to any other in-memory database we use. So this is just an initial example of how to use a real relational database, but in this case, still an in-memory DBMS. In the next videos, I'll show you how to use not the H2 relational DBMS, but other DBMSs as MySQL and also MongoDB. And when we use those databases, we'll see that all we do with the database will be persisted even after we close the application and web server. So that's why here the fourth person is not showing anymore. But now we proved that the application runs okay, as well as the in-memory database from inside the Docker container created from that Docker image we've just created. So now for us to push our just created and already tested image to dockerhub, as we did in the last video, you gotta go to dockerhub, sign in, and now create a new repository for our meeting app application. So we're gonna create this repository. Let me put a simple description here. The visibility I'll set as public. Okay, we create this repository for later tagging the local image with its tag to this new repository. So this repository name here, meeting app that we're creating, this remote name will work as the local image name, And for each image we push to this repository, we'll have an identifying tag. If we do not use the tag will be automatically created as latest, but we can define specific tag names for each of the images we are pushing to this repository from this local image. So the repository name will work as the local image name, and on the side of each of the names, we simply set a tag for each of the images. So let's create the repository. Create. Now we have this repository that we can tag to the local image and later push the local image to the remote repository. So let me just copy this path. Now let's get back to the terminal. Okay, so here at the console, the first thing we gotta do is to log in to my Docker account. So sudo docker login. Okay, login succeeded. Now we gotta tag the local image, which is this image here, meeting app, to the remote repository we are using to push that image to. So you simply use sudo docker tag now the local image ID, and next the remote repository path. So the npm 1982/meeting app column the tag name, and as the tag name I'll also repeat the same tag we have for the local image, which is view.1.0.0. Okay, now if we see the images list again, we'll see not only the original image we had, the meeting app, but we see that another image has been created, which is actually the container we are gonna push to the remote container. So we do not push the original image, we push the tagged new image we create from that meeting app original image. So we've created this, another image from the original image in order to push it now to that remote repository. And for pushing it, we simply use sudo docker push the name of the container and its tag. So it will push this image to this container, the npm 1982/meeting app, and this specific image will be identified through this tag here, because this same container name here will be used for any image we push for the same container. So what identifies each image inside that container is the tag set for that image. So the image we wanna push is this one, so we map it to this container name that we're gonna push, and also to this tag which will identify this specific image inside that container remotely. So let's push enter. It's pushing and it's finished. So getting back to the browser, here at my account / the container meeting app, if we refresh now, we'll see that new tag associated to that specific image we've just pushed here at the tags list. So let's refresh here. And now inside my account and inside this container, which will be the same container for many versions, for example, of the same kind of image, we have now the first image we are pushing, or the first version of that image, identified by the tag v.1.0.0. So this is the image we've just pushed. So the full path for this image is my account slash the repository name, which will have many tags inside as we push different images inside it. And for each image, we have the tag for that specific image here. So we could do later pushes for different changes or updates we do inside that image. And we would push to the same repository here, but for a different tag, for example, v.2.0.0 and so on. So now what it remains for us to do, going back to the terminal, let's clear everything. And also let's prune or clear all local images and containers and internet and volumes from our local Docker engine system. So sudo docker system prune -a or -o. This will erase all the images, containers, internets, and volumes we have saved in our machine. Yes. Okay. So now, if we use sudo docker images, we have no more images, and also we have no more containers saved locally. So now what I want to do is to test to pull or to run that remote image from this repository here that we've just created and see if we can run it again as a local springboot application after we download or clone that image and create the respective container. So for that, we just have to use sudo docker run in the IT mode, and the complete path to that image, which is DNOPM 1982/meeting-app v.1.0.0. So this is the complete path for that image tag. And don't forget to map the ports from inside the container that will be created from this image to the ports that our browser will use of our local file system to access that Docker inner port. So that's it. Let's press enter. It will not find the image locally. It will download that image from the remote repository where we've pushed it, and then it will run our enterprise Spring Boot application from inside the Docker container created from that remote Docker image we are now downloading or pulling from dockerhub. Okay, so it pulled the image from the dockerhub, it created the container, and then it's starting the container by starting also the jar application inside it. So everything seems okay. And now let's just test through the browser at localhost :8080 and the context path here /. Okay, here is our application running again. And if we stop here, sudo docker ps-a, it will have exited. And now if we tested the browser again, it won't find the application nor the Tomcat web server anymore. Okay, so this proves that we were able to create a Spring Boot application, or in this case, just get it from my GitHub repository and clone it locally. Then we built a final jar executable file using Maven from inside IntelliJ IDE. Later, we tested that jar with java- jar command, and it ran the application okay, locally outside Docker. Next, we created a local Docker image for that jar application and tested that local Docker image, and it ran okay. Both the application as the Tomcat web server inside it and the relational in-memory DBMS. We are using the H2 DBMS. And finally, we shared that just created image to a remote repository at dockerhub. And after cleaning all the images and containers and volumes and internets we had locally, we then pulled back that image to our local system and ran it again. And when running, we created the Docker container, and by starting that container again, we were able to run again the Spring Boot application successfully as in the other cases. So this is it for this video, and I hope you have enjoyed it, but I still have a lot to show you, so many more videos are yet to come in the near future, so stay tuned for any more videos regarding this Docker series. So if you want to go to my YouTube channel, you have there all the playlists for all the videos, including some other playlists from other themes about application development. And if you want, you can subscribe and be notified about the new videos I'll be launching soon. So thanks again one more time, and see you in the next video. Bye bye.